whole page. So this is a fourth one where basically added the split the capacitors, and then I think anybody sees a mistake in this one? There's no mistake. You see, there's no capacitance here. This is different from the other one I showed you. So what I'm saying is there is a, the previous one showed as a front end inductor and a switch at the ground, right? So that was a basically boost type. But if I put inductor to ground, like in a flyback, and then a switch in series, then it's a flyback input. But what is the flyback input doing on this converter is basically that you can convert this inductor to two winding structure, but now this inductor is essentially doing bridgeless PFC, but using the transformer of the flyback type, which, as we know, because of this, it has a still storage on the primary side, but no storage on the secondary side due to the capacitance on the secondary side. So let's see how would that be handled. So this is the operation of this in a positive on time and off time, and you can see this and further discussion of the bridges PFC operation of this converter. And this is again using resonance and describing how it operates. And then you have non-isolated version describing what's taking place, and eventually single resonance circuit in that case as well. And these are key equations. Remember, we talk about a ripple of energy transferring capacitor is ripple peak-to-peak ripple current time cosine resonant current. Then you have ripple is peak load current times the resonant natural impedance, which is resistance defined by this, resonant frequency with this, and resonant radial resonant frequency and eventual frequency. And then sine wave current. And sine wave current is instantaneous, proportional to peak sine wave current, and resonant capacitor instantaneous voltage have a ripple cosine, sine and cosine. Okay, so there is here, and this is a implementation with these two IGBTs in parallel or two MOSFETs in parallel. And then next one here is the waveforms and two DC to DC converters in one. What is that one? Let me try to remember. You know, oh, beautiful. I'm reminded of some of the good things I've done. Okay, so you know what's the advantage of this converter? Anybody volunteers to say what is the advantage if you look at the figure 14?
It has buck boost property.
So what is the buck boost doing compared to boost?
Based on this figure, it can also step down the voltage because it has a gain from zero. It starts gain from zero to.
And then explain us more, because that's correct. Explain us more. What is that important from a practical standpoint?
Because we can obtain at the same time power factor correction, and also depending on the load, we can have a lower output voltage than the input, not only to boost it.
Okay, I would add one more thing. That's correct, but the most important one is what is the problem when you had only boost characteristic, which is shown with this dotted line. Boost characteristic started with 1.
Inrush current.
Absolutely, absolutely. What it means is that each converter operates with a boost characteristic. When you turn on the power at startup, output capacitor, whether it's non-isolated or isolated, output capacitor at 0 voltage. And what happens at that time, you suddenly put a pump, and a boost converter has to peak charge the output capacitor until it gets to the input voltage. And then from there, operating duty ratio can increase the voltage. So you have a so-called inrush current, and you have to have inrush resistor and all other complicated circuit. But That is one reason why the step up, step down characteristic initially is good, because it has no problem with the startup. You start up at this point, and then you don't have to have inrush current protection, resistor, and what other. What is advantage now, in addition to this inrush current elimination? What is advantage of charging electric car with the voltage which is from 0 all the way to 400 volts that you want to charge batteries, versus starting from 1, which means in this case, nominal input voltage on electric car is, say, 320 volts when you're electrified, and it can charge to 400 volts full. In other words, it charges with a certain range. And if a voltage range drops with the 300 volt, what happens with the Tesla batteries? Dead. And the only way I remember that Alan Kokoni told me what they were designing the original charger for electric car, which is Roadster, which is predecessor. What they had to do is, if that happens, you go to 300 volts, there is no way you can now start charging because you're out of range. So what is the only way doing? You have to take the whole car, put it on a trunk to take it over to the next station, which has a 220 volt line, and then use the 220 volt line to start charging it, because you're out of range, you see? And when you're out of range, the bad news is when you're out of range, most often it happens if you discharge a battery below that and you didn't know that it's discharged and you're not charging it, it's sitting in a garage or whatever. If you roll below range, very often it happens you may have to throw all the batteries because they are out of range and they cannot be restarted back, you know. But the advantage here is you can go to 200 volts or 250 volts and you can still charge the battery, you know. So you extended the range and you didn't make you didn't have to jump to 220 volt line from 110 when you're out of range. You are able to regulate over a wide range, which is what was earlier a question asked, can you do this over wide range? Yes, you can do that over wide range because this, and you know what I call this? This converter has 2 converters in one, remember? And it has a power factor conversion with the 2 gains. From 0 to 50% duty ratio, say, it has a step up, step down configuration. So start from 0 for a reason I explained. And then at a 50% duty ratio, it's change over, because that point, step up gain characteristic has a gain of 2, and the step up characteristic of a boost has the same 2. So they smoothly change from one mode of operation to the other without any interruption. You didn't even know what was happening. So you have 2 gain characteristic in one single converter. That shouldn't be bad, right? So looking ahead, it's like original one with the power factor correction, isolation there. Instead of having 2 diodes on the output, is 2 MOSFETs. What with the present version that we waited for, 8 years until 2018, Panasonic introduced gallium nitride with the 2 gates. You know what the implementation of this with the 2 gates? Anybody wants to comment? First of all, do we agree that the S1 switch should be gallium nitride switch with the 2 gates? Agree? Yes, because this has to be voltage bidirectional. Well, of course, if the input is not DC source, if input is alternating current, alternating voltage, then we need a voltage bidirectional switch. What happens for an input line is AC line, and we need to have DC on the output to charge the battery. What about these 2 secondary switches, S2 and S3? Are going to be active switches, or they can be still passive diodes? Yeah, I showed you it can be passive diode. But the good news is that passive diode can also be the same bidirectional 2-gate gallium nitride, where you use 1 gate to get the diode emulated and the other gate to get the other diode emulated. So you use this GaN transistor, but you use it as a diode with a single gate control, gate 1 or gate 2. And what is the advantage? Because At that time, I don't know what's the state of art now, but at that time, they were making a 650 volt device, which was a gallium nitride device with 2 gates, which has a 35 milliohm on resistance. 35 milliohm on resistance at 4 kilowatt output charger will be at 400 volts is 10 amps. So 35 volts at the 10 amps is a 300 milliwatt, 350 milliwatts, 0.35 watts at the top of the 4 kilowatt output. Nothing, right? Much better than a diode, which will have 1 or 2 volts and not 350 milliwatts. We'll have a 2-3 volts. So therefore, extremely efficient, and it is a which basically acting as a diode. So single 3 MOSFET, 3 gallium nitride devices with the 2 gates. One is using as a voltage bidirectional switch, and the other using as a diode. End of story, right?